this video, we are going to talk about two types of probability, theoretical and experimental probability. Now, in the last lesson, we learned about finding the probability of simple events, and those simple events are all events that fall into something called the uniform probability model, and those are models in which each outcome has an equal probability of occurring. So we're talking about models like drawing marbles from a bag. Every outcome, every marble has an equal probability of occurring. Flipping coins, you're just as likely to get heads as you are to get tails. If it's a fair coin, that would be a uniform probability model. Drawing a card out of a deck of cards without looking, every outcome has an equal probability of occurring. Or spinning a spinner that's divided into equal parts, every outcome has an equal probability of occurring. So those are the types of models that we're talking about in this lesson. So theoretical probability is probability that should occur. It's probability that we calculate. It's what we expect to happen. And this is what we did in the last lesson when we were calculating the probability of an event. And it's what should happen. It's what we would expect to happen. And does it always happen? No. So for example, if you were flipping a coin, if you flip a coin 10 times, will you always get heads 5 times, and will you always get tails 5 times? No, it won't happen every time, but that's what we would expect to happen. And that's what theoretical probability is. It's what we would expect to happen. We would calculate that heads should occur about 1/2 of the time and tails should occur about 1/2 of the time. That's theoretical probability, or in theory, what should happen. Now, that's a little bit different than what we call experimental probability, and this is probability that actually occurs, probability that is observed. So it's what we see happen when we perform an experiment, what actually happens. So if we flip a coin 10 times, how many times did it actually come up heads? How many times did it actually come up tails? That's our experimental probability, what we observe. And then below, we've got the two ways to calculate these different types of probability. The theoretical probability should look familiar. It's how we were calculating probabilities of simple events. And again, it's the number of favorable outcomes over the total possible outcomes. So it's a ratio, it's a fraction. Experimental probability, however, is calculated a little bit differently. It's still a ratio, but it's the observed favorable outcomes. How many times did what we want to happen actually happen over the total number of observations? So how many times did we get heads over how many times did we flip the coin? So slightly different takes on that ratio. So let's take a look at some examples of here of theoretical and experimental probability. So this table shows the outcomes of rolling a number cube 29 times. So on the first column, we've got all of the possible outcomes, 1, 2, 3, 4, 5, 6. And then the middle column is just the tally. So as we were rolling the dice, we just put a tally how many times each outcome occurred, and then we wrote the number in the frequency column. So a 1 occurred 4 times, a 2 occurred 6 times, and so on. So here I want to illustrate the difference between theoretical and experimental probability. So in theory, what is the theoretical probability of rolling a 6? Well, to calculate the probability of rolling a 6, or what we would expect to happen, is the number of favorable outcomes over the total possible outcomes. So when we're talking about rolling dice, there's one favorable outcome, which is rolling a 6, and there are 6 possible outcomes. So the probability of rolling a 6 is 1/6, or about 16.6 repeating percent chance. Now let's compare that to the experimental probability of rolling a 6. This is what actually happened in our experiment. So now we have to look at the table and see what we actually observed happen. So if we look here, we see that a 6 occurred 6 times. So that was the observed favorable outcomes. We observed a 6 rolled 6 times, and then in the denominator is the number of observations. How many times did we roll the dice? And then we saw that we had rolled it 29 times. So our observed, or our experimental probability, is 6 out of 29, which is about 20.7%. So it actually occurred, a 6 actually occurred about 20.6% of the time, even though we expected it to occur about 16.6 repeating percent of the time. So it occurred slightly more frequently than we expected it to happen. And that's the difference between theoretical and experimental. Theoretical, what should happen. Experimental, what actually happens. So again, let's take a look at another example. What is the experimental probability of rolling a 5, and how does it compare to the theoretical probability? So again, the experimental probability is what actually happened, what we observed. So if we look here and see how many times a 5 occurred, it occurred 3 times out of the 29 rolls. And that is approximately 10.3%. So it occurred 10.3% of the time. And then what did we expect? How often did we expect a 5 to come up? Well, there's one favorable outcome out of the 6 possible outcomes. So our theoretical probability, again, is about 16.6 repeating percent. So in this case, we observed a 5 a little less frequently than we expected. So how can we use observations and experimental probability to make predictions? So this table shows the results of a survey that asked 200 teens what they would be doing if they were not online. Out of a similar group of 450 teens, predict how many would listen to music. So here again, this kind of plays on that concept of a sample and making predictions using a sample, but now we're going to use probability. So looking at the outcomes, what was the probability or the experimental probability of them listening to music if they were not online? So looking at the table, we see listening to music. 52 out of 200 teens said they would be listening to music. So our experimental probability or our observed probability is 52 out of 200, which is 26 out of 100, or 13 out of 50, or 26%. We would then expect that about 26% of teens, based on our observations, would be listening to music. So we can use that fact to make a prediction. Well, how many would that be out of 450 similar teens? So I can use any one of these ratios. I can use the percent. I'm going to use the 13/50th. So if 13 out of every 50 teens would be expected to be listening to music, how many would that be out of 450 similar teens? And if you solve this proportion, you get 117. So we would expect about 117 teens to be listening to music. Okay. And then let's try another one. Out of 450 teens surveyed, how many would you expect to say they would be writing or drawing? So again, we look at our observed outcomes or our observations. And if we look at writing and drawing, 10 of the 200 teens that we surveyed said they would be writing or drawing. So our experimental probability of teens choosing writing or drawing is 10 out of 200, which is 1/20th, or about 5%. So we would expect a 5% chance of teens writing or drawing if they weren't on the internet. So how many would that be out of 450 teens that were similar? So 1 out of every 20 would be how many out of 450? And again, if you solve this proportion, you get 22.5. So since we can't have a half of a teen, that would be weird, we would expect about 23 teens, we'll round up, to be writing or drawing. So in summary, we've got two different types of probability. Theoretical probability. This is probability that is calculated. We don't actually have to perform an experiment to do this. We just take the number of favorable outcomes and compare it to the total possible outcomes. It's what we would expect to happen in theory. And then there's experimental probability. This is probability that you have to actually observe. Is you have to do an experiment to find it, and it's what actually happens when you do an experiment. It's what you observe actually happens.